right, let's go ahead and get started with chapter 6. We have normal distribution. All right, so a lot of vocab here just to start with. So normal distribution, that is when we were looking at a bell curve. Okay, so we're working with the bell curve in this chapter. Two properties of a continuous probability distribution. The probability that x assumes any value in any interval lies between 0 and 1. Okay, so again, probability has to be between 0 and 1. The total probability of all of the mutually exclusive intervals within which C can, that's sorry, a typo there, can assume a value is 1. So again, okay, you have the probability of x is between 0 and 1, and the sum of the probabilities is 1. Okay, this is a normal distribution curve. Okay, now in this curve, we call this a bell curve because it looks like a bell. It's actually called a Gaussian distribution, just so you can see that. Gaussian. You may see it referred to that. Gaussian distribution. Used throughout sciences, both of those. Couple properties of our curve, okay? So first property is that this area under this curve, if I were to color this in and find the area, is 1. Okay, so the area, the total area of the curve is 1. And when we are referring to a normal distribution curve, area is equal to the probability. Okay, and it's this under the curve. This is your area. If I were to color all of this in. The area is the probability. Okay, and we're looking at it on a curve now. And the total area under this curve, if I were to find the area of it, it is 1. Which means 50% on one side, 50% on the other side. You can split it into 4, etc., etc. The curve is going to be symmetric about the mean. Okay, which means 50% below the mean, 50% above the mean, or left and right. Not skewed. It is normal distribution, so it is perfectly symmetrical. And then the last characteristic is the two tails of the curve extend forever in both directions. Okay, so we could imagine here that this is just going to keep going to the left and going to the right. And how does that work if the area is 1? It just is 0.00000000000, you know, it just keeps going closer and closer to 0 as we get further to the right and to the left. Now, since the graph of any normal distribution is symmetric about the mean, the area under the curve to the left of the mean is 50%, so 0.5, and to the right is 0.5. So if I were to take this curve and split it in half, I've got 0.5 on the left, 0.5 on the right. All right, now in example 1.1, you have, let's just read this here. If you look at this graph, let's first look at the shaded area. Okay, you have the shaded area is shaded from 1 or -2 to 1. Okay, so we're looking at this area here. So if I just look at this and I guess what the area is, I haven't read this in a while, so I'm going to look at that, and I know that's got to be more than 50% because it looks like it's covering more than 50%, so I'm thinking maybe like 75%. If I just look at that and say how much of that is covered, it looks like to me about 75%. Now, if I read this, this depicts the probability that a value x is between -2 and +1, okay? Using the standard normal distribution, which we'll talk about in a little bit, okay? The actual probability is 0.8186. So I was close with 75%. It's actually more. It's 81%, 81.86. Notice that the solution does make sense geometrically. This is 0.8186, and then the unshaded area is the remaining 19 and such percent, okay? Since the total area under the curve is 1, we shaded most of the area under the curve, so it follows a solution should be a value close to but less than 1. Okay, so when you are doing this, a lot of the problems, you're going to want to draw out a curve and see if your answers make sense as far as how much you've shaded. Okay, so now let's talk about what these are. So just some notes first before we do it. Okay, so important note. In any normal distribution, the probability of x assuming a single value is equal to 0. Okay, so the probability that x equals a, that a would be 0, equals 0 for any single value. So this follows that the probability that x is between a and b, it just means a is less than x, which is less than b, or that x is greater than or equal to b is x is greater than b. What does this mean? This means the probability is an interval. Okay, that's all that means there. The shape and position of a normal curve is determined by its standard deviation and mean. So we're just going to write here SD for standard deviation and mean. The notation to specify a particular normal distribution is x curly thing n, mean standard deviation. What does that mean? Where you have the mean and standard deviation, etc. Okay, so for instance, x is equal to n 0, 1 is the notation for the standard normal curve that has a mean of 0 and a standard deviation of 1. So if you see this notation here, this just means a normal curve with a mean of 0, standard deviation of 1. Okay, which is what we call the standard normal curve. In particular, the position of a normal curve is determined by its mean, whereas its shape is determined by its standard deviation. A normal distribution will always be centered about the mean. Notice in example 1 that the mean is 0 and the standard deviation is centered about 0. Now, typically, what we looked before, a smaller standard deviation is going to give you a narrow curve. Okay, so that might look something like this, where it's very high, like that. Whereas a larger standard deviation is going to make this more spread out, so it'll be a wider curve. Okay, so that might look more like this. Okay, the standard normal distribution is a normal distribution of standardized values called z-scores. Okay, z-scores are measured by units of the standard deviation. Okay, a z-score, which is also referred to as a standardized score or a z-value, indicates how many standard deviations above the mean or below the mean an observation is. Okay, now a z-score is going to go between it can be actually higher than -3 and above -3, but typically remember when we were looking at the empirical rule, you had standard deviations 1, 2, and 3 values from the mean. Correct? So before I look at this example here, I'm just going to go ahead and put this as, okay, let's say this is 0, 1 standard deviation above the mean, 2 standard deviations above the mean, 3 standard deviations, and then -1, -2, -3. Okay, this is called a standard normal curve. Okay, a standard normal curve has a mean of 0 and a standard deviation of 1. Now, if I were to take this example and put it on the standard normal curve, that is called standardizing my value. This means that I can take any mean and standard deviation and put it on the same curve. That's why we do this, because then we'll have the same z-scores, which are your areas, for anything. So if I say, suppose the average test score for a statistics class is 75 with a standard deviation of 10. I want to standardize that. All that means is that I'm going to take that and put it on this curve here. So that means at 0, that's my mean, I'm going to put 75. And then my standard deviation is 10 points. So I'm going to add 10 points 3 ways. So 85, 95, and 105. And then I'm going to subtract 10 points, 65, 55, and 45. Okay, now all this means is that these scores, -3 to +3, correlate to the values that we've placed below them. Okay, but now on the standard curve, I can say what z-score corresponds to the value of 85. Okay, so that's what that says. Calculate this z-score that corresponds to a test score of 85. That's 1. 85 is 1 standard deviation above the mean. You can clearly see it on the curve. Okay, then what about a test score of 55? Well, 55 is -2 standard deviations below the mean. What about 90? Well, 90 is not on here, but 90 is in between 85 and 95, so that would be 1.5. Okay, so the goal of standardizing the score, putting it on this scale with 0 and 1, is so that we could take any mean and standard deviation and put it on the same curve. Because you are going to have finding the area of these values, which is right here, a z-table. Okay, these are your z-tables for values below 0 and then above 0. Okay, these are your areas. Notice they never get more than 1. Well, the value here. But yeah, they go up to 3.4. So you would find the correlating value for any score. Now, I didn't print these out for you guys. You are free to print them out and bring them to the test on your own, but your calculator also stores these values for you. So you can use your calculator to find them. Okay, so I'm going to show you how to look them up on the table and to use your calculator. So let's go. Let's just look at a couple more scenarios here so I can show you, and then we'll do some examples. Okay, so there's going to exist 3 basic probability scenarios that we're going to encounter. We need to learn how to solve each type and understand why. All right. So the first one is the probability that z is less than a. Okay, so what that looks like is we're going to the left. Okay, less than would be left on the number line. So this is just like a number line. Okay, so here's your normal curve. Okay, when you see the less than, that means you're going to have a for a value, and then you're looking for the area to the left, because less than goes to the left on the number line. Okay, now the next one, z is greater than a, is going to be to the right. So the next scenario, I'm going to put this over here. So this is z is less than a. Normal curve, let's say this is a right here. Greater than would be going to the right. And then the third scenario is that z is in between a and b, which just means it's going to be between two values. It's not going to be going to either extreme value. So let's say it's going to be between here and here, a and b. Okay, now let's say we're going to do some examples here in a second. So there's a couple different ways that you could do this. I want to just do it with some examples. So we're going to skip the second part. All right, so the standard normal distribution has a mean of 0 and a standard deviation of 1. The area to the left of 0 of the mean is 0.5, and to the right is 0.5. So let's look at some examples. Okay, so we want to find the probabilities, and here's our values. So the probability, z, okay, is less than 2.38. So they're not always going to be whole numbers. So when I look at my normal curve, here's 2, here's 3, 2.38 is probably about right here. And if I'm looking at less than that, that's going to be this area here to the left. So I would want to shade all of this in. Okay, now looking at that, you would assume that that value is going to be, what do you guys want to guess here? Yeah, it's probably like 95 or something like that. It looks like it's most of this is shaded in, except for this little tiny bit over here on the right. So to find that, you have two ways to do this. First is looking it up in the z table. So this is a z value of positive 2.38. So if I bring over my z table, okay, I'm going to go to the positive table, and this is just ztable.com. I just typed in Google z-table and click the first one. Okay, you're going to go to 2.3, which is right here, and then you're going to find the corresponding value. Let me make this a little smaller. There we go. Okay, so 2.3 won't let me highlight on here, and then 2.38 is going to go right there. So there's the 0.08 and 2.3. So you want to find where those meet, which is right here at this 0.9913. Okay, that's going to be that area. So it's actually 99%. Now the z table, all of these scores are always going to show you to the left of z. So since this is a less than, that's fine. Okay, but if it's to the right of z, we have to do another procedure. So it's always going to give you the value to the left. So it gave you 0.9913 when we looked it up here. So 2.38, 0.9913. Okay, so look up in table. And we got 0.9913. And that is this area here in the green. Okay, now you can do this in your calculator. So let me find my calculator. So there's actually different methods for the 83 and the 84. So let's do both. Uh-oh. My 84 somehow undownloaded from my computer. Oh. Okay. Hold on 1 second. All right, got it. Let me make this just a little smaller. Okay, so now we're going to look this up in your calculator. So it has it stored in here for you. So let me see if I can remember. Yes. All right, so you're going to go to second, then the distribution again, just like we did for our probability tables. And now we're going to look at the second one here, normal CDF. That's what we want here, normal CDF. Enter. Why is it all the way over there like that? Okay. Sorry, just playing with it. Okay, so does yours come up with a thing on there? Why is mine not doing that? That is odd. Okay, let me show you on here what you're going to do. So you're going to do the lower value and then the upper value. So you're going to go left to right when you do these. So for this one, if I look at my value here, the value on the left, remember this extends indefinitely this way and this way. So what would this value be on the left? It would be negative infinity, but we can't write that in the calculator. So every professor will tell you something different for this. I just use negative 99 and positive 99, and that's fine. Some do negative 999, positive 999. That's fine too. But what you're going to do for the calculator is second, then your distribution. I'm just going to write the directions here. And then it's normal CDF. Okay, then you have your lower value, or your lower limit, I think it says, and then your upper limit, which is left to right, and then your mean. So on the 84, it should pop up with a screen that asks for the mean and the standard deviation also underneath that. You'll put 0, and then for the standard deviation, you're going to put 1. But for some reason, it's not popping up on here. So here I'm just going to put negative 99, comma, 2.38 for my upper value. And then it'll give me 0.9913 and also further decimal places. Maybe if I do that one. Oops. All right, this one is giving me issues. It's like one click behind on everything. Okay, second, distribution. I don't want vars, I want second. All right, that one's not working. Okay, so does anybody need help with their calculator since this one isn't coming up the way you guys see it? Yes. Okay, so remember the upper limit is 2.38. You're going left to right here when you do that. Okay, so let's take a look at, well, we can take a look at C. So when I look at C, I have negative, so Z is greater than negative 3.24. Okay, so here's 3, negative 3.24 is like right here. So this actually is almost the whole curve, right? This should probably be pretty close to 1. When I color this in, this right here, this area right here is blank. Okay, so if I'm going left to right, this is negative 3.24 on the left, and it would be a positive 99 on the right. So my command on the calculator would be normal CDF, and then my lower limit would be negative 3.24. My upper limit would be 99. And then let's see what that gives us. So normal CDF, lower limit would be negative 3.24. Upper limit 99. See, now it's showing it. That's so weird. Mean of 0, standard deviation of 1. Paste. 0.9994. So typically these are going to be 4 decimal places because that's the way it gives it to you on the Z table. So 0.9994, that's this right here. Now how do you find this in the table? So let's say you're using the table for this one. Okay, so you have negative 3.24. So go to the negative table, which is up here. So negative 3.2 and negative 3.24 is 0.0006. But remember, the table gives you the area to the left of the curve. So what this 0.0006 is this right here. This is 0.0006. So if I want to do it in the table when it's going to the right, I would do 1 minus the value in the table. And then that would give me 0.9994. Okay, because the table is always going to the left. Yes. Yes. It is asking you for the probability, so it's asking the area to the right, because the probability the Z is greater than negative 3.24. So then if I look at B, this is the probability that Z is greater than 1.75. So it's going to the right. 1.75 is about right there. So this is the area I'm looking for here, shaded in blue. So if I want to look this up in the table, it's going to give me the value on the left of this. So let me see here what that would be. So 1.75 in the table is 0.9599. Okay, so that's this, which means the area shaded in blue is 1 minus 0.9599, which is 0.0401. Okay, or in my calculator, this is how I would write it if I was showing my work. I would go normal CDF. Okay, the left value is 1.75, and we're going to the right. So the upper value is 99. So I would go second, distribution, normal CDF, and then I would go 1.75, upper limit 99, mean of 0, standard deviation of 1, paste. So 0.0401. Okay, now for D, this is going to be in between two values. So here you would go negative 1.63 and then 0.24. So maybe that's like really close to 0, about right here. Okay, those are your values, so this is what I'm looking for, this area right here. So in your calculator, this is simple. You just go normal CDF. Your lower limit is negative 1.63. Your upper limit is 0.24. And you would keep the mean and the standard deviation at 0 and 1. So that would give you 0.5433. Okay, and again, that represents this shaded area right here. Now, if I wanted to do this in the table, okay, you're going to look up both values in the table. So here I would look up 0.24. I'm going to look up the leftmost value first. So 0.24 gives you 0.5948. So let me write that down. Okay, and then negative 1.63. Negative 1.63 is 0.0516. And then you're just going to subtract them from each other, okay? Because here's what this is actually giving you in the table. Okay, so let's say this is 0.24. This is the 0.5948 here. And then this is negative 1.63. Okay, it's giving you both of these values. If you want the one in between them, you're subtracting that out, okay, because you want to subtract the 0.516 so that you're getting this here, the remaining value. So we do 0.5948 minus 0.0516. And that will also give you 0.5432. So you can do that using the table as well. All right, example 1.6. Remember the empirical rule? Do you guys remember that? We had, what was the probability of what percentage would fall within one standard deviation of the mean? Do you guys remember? That was Chebyshev's theorem. That's 3 standard deviations. 68% within one standard deviation of the mean. 95% within 2 standard deviations. And 99.7 within 3 standard deviations. Check it. Okay, I'm going to draw these, color these in first. Okay, so this should be 68% when I look this up within one standard deviation. This should be 95%, and this should be 99.7. If I go to my calculator and go normal CDF, lower limit of -1, upper limit of +1, go -1, +1, mean of 0, standard deviation of 1. 0.6827 is the exact amount there. So 68%. If I do the same thing with 2 standard deviations, -2, +2, I get 0.9545. And then 3 standard deviations, -3 and +3, 0.9973. Okay, so the empirical rule here will stand. Okay, so that's 68, 95, 99.7. So that does come back up from chapter 3. All right, so let's look at a couple of examples here. Okay, so if we look at this one, we have the z-score that z is less than -5.25. So if I go to my curve and I go to draw that, that's way over here. And then we want the score to the left of that. So this is what we're looking for here. Okay, so that is probably going to be pretty close to 0, if not 0, when I look at that. So if I'm going to put that, I can't even look that up in the table. Okay, so I would have to do this in my calculator. And if you didn't have a calculator, you would just put 0, because it's not even on the table. But -99 to -5.25, okay, if you look at that and you know that this area here is 1, that's got to be close to 0. So I would go normal CDF, -99, -5.25 as my upper limit. And you've got 7 zeros and then 7, or actually 8. So that's going to be 0. Okay, remember your probability can be 0. All right, and then let's look at example C, the probability that it is greater than -7.28. So if I put that on the number line, okay, and I'm going greater than that, that's all the way over here and then into these. So what do we think that might be? If we're going to the right, though, I'm shading all of this and this. 1, yeah. So this would be normal CDF. We would have a lower limit of -7.28 and an upper limit of +99. And that should be close to 1. Oh. And we get 1 for that one. All right, and then probability that z is greater than 6.28, greater than is going to the right. So what do we suppose that one is? That one's probably going to be 0. we're going to the right. We would go normal CDF. We would go lower limit of 6.28, upper limit of 99. And then you have 9 decimals and then a 1. So definitely 0 there. And then for D, you have the probability between 0, so here's 0, and 4.88, which is going to be about right here. So now we're looking at this area here. What do you guys think that's going to be? Yeah, that should be 0.5. Okay, if we check that, that would be normal CDF with a lower limit of 0 and an upper limit of 4.88. .4999999. So we can round that to 0.5. Okay, so that's the first part of chapter 6.